So this is the second chapter, vectors and equilibrium. In this chapter, we will see mainly definition of vectors. Physical quantities that have both numerical and directional properties are called vectors. This chapter is concerned with vector algebra and its application in numerical problems of equilibrium of forces and equilibrium of torques. So basic concept of vectors, we will see what is meant by vector. As we have studied in school physics, there are some physical quantities which require both magnitude and direction for their complete direction, such as velocity, acceleration, and force. These are called as vectors. In books, vectors are usually denoted by bold-face characters such as capital A, D, R, and V. While writing in handwriting, we put an overhead over the letter like D with an arrow. If we wish to refer only to the magnitude of a vector D, we use light face type such as D. A vector is represented by a directed line. So this is how you can define vectors, 2 to 3 lines. Then there is a representation. How to represent a vector? Vector is represented graphically by the directed line segment with an overhead. The length of the line segment according to a chosen scale corresponds to the magnitude of the vector. This, these are some rectangular components in a plane x and x dash, y and y dash. This is a two-dimensional Cartesian coordinate system. So next is the rectangular coordinate system. Two reference lines are drawn each other as shown in the figure 2.1a. These are known as coordinate axes and the point of intersection is known as origin. This point O is called origin. These x dash, x and x dash, y and y dash are called coordinate axes. This system of coordinate axes is called Cartesian or rectangular coordinate system. One of the lines is named as x-axis. This one is known as x-axis and the other is y-axis. X-axis is taken as horizontal axis with positive direction to the right and y-axis as the vertical direction, vertical axis with the positive direction upward. So this is the positive, having x value positive, y value positive. This is having x value negative and y value positive. Similarly, here both x and y are negative, and in this portion x is positive and y is negative. The direction of a vector is in a plane is noted by an angle which represents the line of the vector x with the positive x-axis in the anti-clockwise direction as shown in the figure. This angle is represented by theta in counterclockwise or anti-clockwise direction. This is a vector having a coordinates of point A and B. This notation means that if we start at origin, we reach the point B by moving A units along the x-axis and B units along the positive y-axis. This point A into B shows that we move x units in x direction and y units in y direction. The direction of a vector in a space requires another axis which is at right angle to both x and y axis. As shown in the figure 2.2a, the third axis is called z-axis. Direction of a vector in space or 3D, we require another axis which is this one, z-axis. The direction of a vector in space is specified by three angles which the representative of line of a vector makes with x, y and z respectively as shown in the figure 2.2b. The point P of a vector A is thus noted by three coordinates A, B and C. In 2D we have 2 points A and B. In 3D we have three axes x, y and z. So the point P is represented by three coordinates like A, B and C. This angle is represented as gamma between a and x-axis and z-axis and this vector a. This angle is beta, which is between y-axis and this vector a. Between x and this vector a, angle is represented as alpha. The next video will see addition of vectors, resultant vector, vector subtraction, and the contents of this chapter. So stay tuned with this playlist of this part 1 physics.